Hi, 7th grade. Happy New Year. Welcome back. We are going to start today with a little bit of review before we dive into our learning. Please grab your notes if you're not already set up, and come back when you're ready to go, because all of this should go in your notes today. Okay, quick review. Before the break, we were working on ratios. There were 3 types. If I use 1/2, we can write that 1/2, 1:2, and 1/2. We also worked on unit rate and unit cost. That's whatever you're talking about, if you're talking about miles per hour, if you're talking about a cost per item, whatever it is, unit rate is per one item, okay? And you're always dividing to find that. This is where you have like a group of some things, whether it's for sale. I know that we've talked about in class, like eggs. You can't buy 2 eggs, right? But you can still get the best deal by knowing what the unit rate is. And then we did proportions, which is 2 equal ratios. So 1/2 is equal to anything that would reduce down to 1/2. And then we also learned how to solve them, right? So we cross multiply and set it up as an equation. So if we have a missing, m for missing number, over 40 is equal to 8/10, we cross multiply and set up an equation to solve. So this would look like 10m equals 8 times 40, right? And then if 10m is equal to 320, divide by 10, divide by 10, m equals 32. Okay. Sorry. I didn't realize I wasn't on there. All right. So hopefully now that that's all fresh in your mind, we tested over the break. I entered all those grades over the break, so your grades are all current. If you haven't been on PowerSchool, you should check it out. Today we are moving on to 5.5, which is on page 207, and we're going to be working with similar figures. There's some definitions we need to go over. The first one is polygon. This is straight from the book. A polygon is a closed plane figure formed by 3 or more lines. The line segments can't cross. So think your basic flat figures, a triangle, a square, octagon, all of those. Similar in our math text has a shape that sort of looks like this. It's kind of like the top of pi. And it's 2 shapes that have corresponding angle measures, and the corresponding sides are proportional. I've written the symbol again there for you. So if we say triangle ABC is similar to triangle EFG. Okay, if we wrote it, it looks like this. There's a triangle shape to show us that it's a triangle. And when we think similar, it's not congruent. Congruent means exactly the same. Similar means more like, I didn't leave enough room in my notes, but if I was you, I would add this in this section. And since we already were given A, B, C, I'm just going to use those. Think of like a mom shape and a baby shape, right? So you have like a big shape and a smaller shape. They don't have to be going the same direction, right? If EFG was flipped, these are congruent. These are the exact same. This triangle here and this triangle here, they're still similar, okay? And what this definition says means that the corresponding angles, they're all the same measure. It doesn't matter if it's big or small. The distance between on the inside is the same. So B and F are the same. Some of the ways that we show the same is with like a line through. Sometimes they'll just give you the measure, but like A congruent to E, these two are the same, so maybe we would do, just so that it's different from the bottom, 2 lines, and then C is congruent with G, so maybe I put 3 lines there. So if I was to break this down, I'm just going to ignore this one for now, right? It's all the same, but here we go. If angle A is equal to angle E, angle B is equal to angle F, angle G is equal to angle C. These are all the same. Okay, they're corresponding angles. So I'm going to point. Means they're in the same location, right? But in 2 different shapes. So this is the top in both of them, right? B sort of looks like in my drawing a right angle, so F would be the right angle. I hope that makes sense. Okay, the second part of this is the corresponding sides are proportional. So that means side AB, so this here from A to B, is similar to side EF. They're not the same. They're similar because they are proportional. Okay? But they're in the same location. It's this line and this line. Okay, so then the top, the hypotenuse, AC, that is going to be the same or similar to EG. So AC is in the same location as EG. And then lastly, the bottom, so BC, is similar to FG. Okay, corresponding. This is the same location as the bottom of that one. Okay. Corresponding is the same object, so the line or angle, that appears in the same place on 2 shapes, okay, similar shapes. So we just explained in an example what these words mean. Okay, I'm going to give you a second to write that out. And then we're going to try one. So our example says find the value of x. They've given us 2 triangles. We've got triangle DOG, and it's similar to CAT, triangle CAT, and it says this in the book. I didn't write it out. It gives you this information. So in order to find the value of x is here, it's this line. We have to use this information that we know the sides are proportional. Proportions are 2 equal ratios, okay? So that means I need to pick numbers to make a proportion. I always start with the variable. The variable is in this smaller triangle, So x comes first. The line that is corresponding, this CA, is DO, right? It's the left in the little, so it's the left in the big. So that information goes on the bottom. You guys are going to have to build your proportions. Okay, so you want to make sure you pay careful attention to where the numbers go. Okay, so I'm actually I'm going to draw a little triangle and then I'm going to draw a big triangle to help me keep these organized. So the information in the numerator is all coming from the small triangle. The information in the denominators is all coming from the big triangle. So then the other fraction just has to have the right corresponding sides. We can pick the top, let's call this the top, 32 and 40, or we can pick the bottom, 24 and 30. I always pick the smaller numbers because I'm less likely to make a mistake. So that's what I'm going to do for this example. So I'm going to pick 24. That's my information from my small triangle, so it goes on the top. It was this side here, TA. So that means I have to use the corresponding side, so GO, 30. And 30 came from my big triangle. Okay, so now that my proportion is set correctly, I can cross multiply and solve. So I'm going to have 30x is equal to 24 times 50. So 30x is equal to 24 off to the side times 50. I'm going to use inverse operations to get the variable alone. What I do to one side, I have to do to the other. 3 goes into 120 40 times. I took a 10 off of both. I divided them both by 10 first, just because there is an extra 0. Okay? The value of x is 40. You're going to be doing this today. You're going to be building your own proportions so that you can solve for the missing variable. Okay? The second type of problem you're going to be doing is finding the measure, the missing measure. So, don't want to do the one they've given you. Here we go. Let's say here we have, we'll do KCL and PMW. And we'll say that this is a right angle, and we'll say that in this one, it's 30 degrees. So we only have one measure in each, okay? And let's say that the question says, find measure of angle P. Okay? Find the measure of angle P. So here is angle P, this one up here. And we don't have that on either triangle. But what's important is that a triangle, if I say A, B, and C, angle A plus angle B plus angle C is always equal to 180. 180 degrees, every triangle. Okay? So if we have a 90 degrees, and if we know that they're similar, then that means the measurements have to be the same, okay? So if this is 90, this is 90. If this is 30, this is 30. And we can use what we know to solve for the two, more specifically the one that we need, right? For the ones that we don't. So 90, sorry, I'm running out of room. I'm going to put it on here. So for KCL, I have angle K is missing, but I have angle C is 90 and angle L is 30, and together those all have to equal 180. So 30 plus 90 is 120. And if I set this up just like an equation, I get the variable alone. And K is equal to 60. So 60 degrees is my measurement for both K and P. So the measure of angle P is equal to 60 degrees. Let's do one more like that. Example 3. Okay, so let's say for this example, we have triangle MNO and PQR, and they're similar. And let's say that O is 53 degrees and Q is 44. And that's all we know. Okay, that's all they give us from the problem. So we know that if this is true, if they're similar, then angle